Welcome. Today we're doing section 4.3, which is section 4.6 actually in your book, but for us it's 4.3. It deals with stretches and shrinks of the absolute value function. So our I can statement for today is I can perform transformations including translations, reflections, and stretches on quadratics, square root, and absolute value graphs. But before we get into stretches and shrinks, what we need to do is finish up what we had yesterday. Yesterday we were working with the square root function as one of our paired functions. Remember, it looks like the swimmer's arm. We still have a few equations that we need to solve for x that include a square root. So if you can pause the video and take out your notes from yesterday, we can get started on finishing up those last three. So we can pause the video now. Okay, now that you have this sheet out, what we're trying to do is when we solve these equations, we want to get this square root of negative 3 plus x by itself, or square root of something by itself. In this case, it's already by itself, so what we need to do is just square both sides. And what will happen then is our squared and square root are going to cancel each other out and leave us with just negative 3 plus x equals 5 squared, which is 25. And then from here we solve for x. So I add 3 to both sides. Our 3's cancel here, and we get x equals 28. Next, we have a little bit more complicated example, a little more complex. But once again, our goal is still to get this square root, whatever is under the square root by itself, so square root x plus 4 in this case. So what that means is we need to do some simplification first. So we can subtract 8 from both sides. Our 8's will cancel here, and it leaves us with 2 times the square root of x plus 4. And then 2 minus 8 is negative 6. Once again, we still have this square root of x plus 4 not alone, so we have to divide by 2. Okay, cancel out our 2 here. And that leaves us with the square root of x plus 4 equals negative 3. Now from here is when we can do our squaring both sides. We need to cancel out that square root. So square root and square root will cancel out and leave us with just x plus 4. Negative 3 squared is negative 3 times negative 3, which is positive 9. And to solve for x here, we can subtract 4 on both sides. And we get x by itself here, and 9 minus 4 is 5. Okay? So I'd like you to go to the next example. If y equals square root x minus 4 minus 3, find x when y equals 2. So I'd like you to pause the video and go ahead and try this one on your own. All right, you should have completed this one. We're going to take this y equals 2 and plug it in for y over here. So we have 2 equals square root of x minus 4 minus 3. Once again, we want to get what's underneath the square root by itself. So in this case, we have this x minus 4. We're trying to get it all alone. So that means we need to add 3 to both sides. Our 3's cancel here, and it leaves us with root x minus 4. And 2 plus 3 is 5. We do have x minus 4 by itself now, so we can go ahead and square both sides of our equation. 5 squared is 25, and then our square root and squared cancel each other out to leave us with just x minus 4. And our last step is to solve for x. Add 4 on both sides. Those cancel there, and we have x equals 29. So that's it for solving equations with square roots when we're solving for x. What we're going to do now is we're going to move into the absolute value function. So you should take out your notes, your green sheet that has the absolute value function at the top. So you can pause the video now to take that sheet out. All right, first off, our definition of the absolute value. What the absolute value is the number's distance away from 0. And the key thing with absolute value is we're always going to have positive values. Okay, we will never have negative numbers with absolute values. So just going to some of these examples here. When we're trying to find the absolute value of 3, how far away from 0 are we? Well, we're 3 units away from 0. If we want to find the absolute value of -4, we're thinking how far is -4 from 0? Well, it's 4 units away. So the absolute value of -4 is +4. And then our last example here, absolute value of -x, doesn't matter what number we have. If it's a negative number, the absolute value is going to be the positive value of that number. So if we have -20 and we want to find the absolute value of it, it's going to be +20. Over here on the right, we have a couple different problems. It says if the absolute value of x equals 3, what could x be? So what this is saying is if x is 3 units away from 0, what could x be? And in this case, it could be +3, but it also could be -3, because -3 is also 3 units away from 0. Okay. And we can do the same type thing that we did for that problem for the second part here. So absolute value of x plus 2 equals 5. So x plus 2 can be +5, or x plus 2 can be -5, because both 5 and -5 are 5 units away from 0. So from here we can solve, subtract 2 on both sides for each one of these. Here we get x to equal 3. Over here we have x to equal -7. So we get 2 different answers for absolute value again. Okay. The last one we'll go through here quickly. So 3 times the absolute value of 5x plus 1 equals 33. So, whoop, too far. Too many extend pages. There we go. So right now we can't set up our equation like our last one where we have a positive and a negative, because we don't have just our absolute value by itself. Here we have this 3 being multiplied. So our first step is to divide by 3 so we can get rid of that piece. So then we're left with the absolute value of 5x plus 1 equals 11. And now from here we can solve this and say that 5x plus 1 has to be either positive 11 or 5x plus 1 has to be negative 11. So let's solve our 5x plus 1 equals positive 11 first. You can subtract 1 on both sides, and we get 5x equals 10, and divide by 5 on both sides. So one of our solutions is going to be x equals 2. Now we have to figure out what our second one's going to be. So once again, we're subtracting 1 on both sides. So we get 5x equals -12. And to solve for x, once again, we divide by 5. Alright, 5's cancel, and we're left with x is -12 over 5. And you can leave your answer like that. If you wanted to write this as a decimal, you could, but -12 over 5 would be an acceptable answer for that one. So again, 2 answers with absolute value, similar to what we did when we took these square roots, square root of values. But let's look at the graph here for the absolute value function. It's going to end up looking like a V, but we'll go through this. So this is for y equals the absolute value of x. So for our table, we have x and y. -2, -1, 0, 1, and 2 will be the values we choose for x. So now we're going to plug these in and see what we get for y. So the absolute value of -2. So again, we can't have positives. So how far away from 0 is -2? And it's 2 units away. Same thing for -1. The absolute value of -1 is 1 unit away from 0. So our y value should be 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And the absolute value of 2 is 2. So when we graph this, -2, 2 is here. -1, 1. We have 0, 0. Over 1, up 1. And then over 2, up 2. So our graph is a V. And our line to the positive values of x, so our line over here these have a slope of positive 1. And our values this way, our line has a slope of negative 1. And so we'll see that coming into play a little bit later on. So here we're going to look at applying some of our translations and transformations to these absolute value functions. So here we have y equals the absolute value of, absolute value of x minus 4. So if minus 4 is on the outside, what this means is it's going to be a shift up or down. And in this case, we're going to be moving down 4. So 1, 2, 3, 4. Up 1 over 1, up 1 over 1, up 1 over 1, and up 1 over 1. And here's the graph of absolute value of x minus 4. Our next one, and you can pause the video at any time if you want to try these on your own. But our next one, in the absolute value, it says x minus 2. So remember, if we're inside of our function, it's going to be translation to the left or to the right, and it's always the opposite sign. So x minus 2 means we move to the right 2, and then plus 3 is up 3. Okay, so this is right 2 and up 3. And from here we can go up 1 over 1, up 1 over 1, and then the other side up 1 over 1 and up 1 over 1. This third one here involves a little bit of what we talked about yesterday when we have that negative value out in front. So we looked at negative values out in front of our square root. And what that did is that reflected or flipped our graph down. Same thing with absolute value. This negative value out in front here is going to flip that absolute value downwards. Okay. But before we do that, let's look at what's going on for our transformation. So this x plus 2 inside the absolute value means we're moving to the left 2. And then negative 1 means we're going down 1. So left 2, down 1. And like I said, that negative out in front means we're going to flip it down. So instead of going up 1 over 1, we're going to go down 1 over 1, down 1 over 1, and the other way, down 1 over 1, down 1 over 1. So our graph will look something like that. For these ones, we're going to write the equations of these absolute value functions. So what I want you to do is pause the video and go through and try some of these on your own. All right. So what you should have gotten for this one is y equals the absolute value, and we're shifted 3 to the right. So it should be x minus 3, all within our absolute value. We're not moving up or down anywhere, so we should we don't have to add or subtract anything on the end. Our second graph here, we're shifting to the left 2, so we should have x plus 2, remember opposite sign. And then we go up 4 units, so plus 4. This next one has a reflection, so we know we're going to have to start our equation y equals negative, and then our absolute value. This is shifted 1 unit to the right, so x minus 1, and then we're up 3, so plus 3 at that vertex there. So moving down to this next row here, this one also got flipped, so we have y equals negative, and then our absolute value. Here we're shifted to the left 3, so it's going to be x plus 3. And we weren't moving up or down any, so we're just going to leave it as negative times the absolute value of x plus 3. Second to last one here, we have y equals, we don't have any flips, so we can just have our absolute value function. We're not being shifted to the left or the right, so we only need absolute value of x. And we moved up 3, so absolute value of x plus 3. And our last one, we're shifted to the right 2. So we have absolute value of x minus 2. And then we're going down 1, 2, 3, 4, so minus 4. And now we have our reflection here. This has been reflected and flipped over. So we make sure we put that negative sign right out in front of our absolute value. So these are review here. So be careful with your parent functions. I want you to give these a shot. So pause the video and find the value or the equations for each one of these functions. All right, so what you should have gotten for this first one, this is a parabola. Our parent function is y equals x squared. Our equation, we've been shifted 4 to the left and up 2. So y equals, in parentheses, 4 to the left is x plus 4 squared. And then up 2, we should have a plus 2. These last two graphs are from the parent function y equals square root x, so our square root function. These are our swimmer's arms, so remember. This one is not going to the right, it's going to the left, so we're going to have some sort of reflection, and this one's going to be with our x's. But our equation should be y equals, we were shifted 2 to the left, so we have x plus 2. And remember, if we're flipping or reflecting to the left, we have to have that negative sign inside of our square root. And then we also shifted up 3, so we can't forget that last piece there. And the last equation here, right up top, so y equals, again, we have our square root function. We were shifted 1 to the right, so square root of x minus 1. And then we went down 2, so we'll minus 2 more. Okay, that's it for today. Your homework is section 4.6, numbers 1 through 5. When you finish this, or if you finish this, go ahead and make sure you have those other homework assignments done. And that's it for today.